Hey folks, we are back with the Unit 2 Day 7 video, and this is video number 2. We're looking at the cross product. So we have, in the last video, went through the big messy derivation and came up with this equation for the cross product of two vectors. And it's a mess. This is really hard to memorize. Every year I do have one or two students who prefer to memorize this, but I don't. Honestly, if you offered me like $1,000 for telling you what the cross product is without deriving it first, because I know I can derive it, I couldn't tell you. I really, really couldn't. So you don't have to memorize this big mess. I will show you a better way. There's a diagram of this on the next slide, but I sometimes feel like the diagram looks harder with these kind of like generic variables, that using the diagram looks harder. So I'm going to go right into an example and show you how this works and go through the process of how to use this shortcut where you don't have to memorize the equations or like this at all. So we are going to calculate U cross V. So the first step in my handy dandy shortcut is to write the components of U twice vertically. So I'm going to write those components twice and going vertically down. So U is 3, -2, 5. So I'm going to write that twice. I'm going to say 3, -2, 5, and 3, -2, 5. And then I'm going to do the same for V. And V is going to go on the right of the U ones. So just to the right of those, I'm going to do the same, write the components of V down vertically twice. So 5, -1, -4, 5, -1, -4. Okay. The next step is to cross out the top and bottom row. So I just actually take a pen or a pencil and cross out the top and bottom. We don't need them at all. Now, every year I have people say, why do you write them down if you don't need them? Like, what's the point? Why don't you just start with the second component? And I actually don't know, and it does seem kind of silly to me. And the only answer I can think of is that in 1996, when my grade 12 teacher taught me how to do this, this is how he did it. And I've just totally gotten in the habit, and I know that I don't need the first one, but every time I do cross product, all the way through university, all the way of like teaching for the past almost 20 years, I still write them down and cross them out. So it works for me. You don't have to obviously write them down and cross them out if you remember what one to start with. So the next thing will make more sense when you see it, but we're going to multiply diagonals. And this is the important thing to remember. We're going to do downs minus ups. So I'm going to use the first one, I'm going to use these diagonals to get my x. So I'm going to multiply the first two diagonals, and I'm going to do the downs minus the ups. So the x is -2 times -4 minus 5 times -1. So multiply, multiply, subtract, down minus ups. So x ends up being -2 times -4 is 8. And then minus, when we multiply there, -5, so it's +5. X ends up being 13. And that's all it is. I don't even normally show this, but while I'm teaching it, of course, like, I want you guys to have a good note with the detail in there. So the next pair will give us the y's. We're going to do downs minus ups. So here we do 5 times 5 minus 3 times -4. So 5 times 5 is 25. Negative and negative is going to be +12, so we get 37. And the last one will give us the z's. So downs minus the ups. 3 times -1 minus -2 times 5. So that's -3 minus -10, so +10. You'd be surprised at how often that, like, double negative, people make little mistakes there. So then you just summarize your final answer, and you actually do have to write it out as a vector, because remember, this is a vector answer. U cross V equals 13, 37, 7. And again, you don't have to show this, like, middle calculation step, but please do be very careful with double negatives especially. And that's it. So this is my process. This is how I do cross product. Like I said, every year there is for sure always a couple people who prefer memorizing and just go ahead and memorize the big messy formula. Whatever way works for you, you just have to be able to calculate the cross product using some technique. So the next one is those same vectors. I'm just going to rewrite them here. U was 3, -2, 5, and V was 5, -1, -4. So we're going to find V cross U. And remember, when we did the dot product, we realized that it was commutative. It didn't matter the order that you did that in. It would be the same. U dot V is the same as V dot U. Is that the same for cross product? So we're going to do it with this one little example and figure out whether that's true. So again, following my technique of not ever memorizing things if I don't have to, I'm going to write the first vector down twice vertically. So 5, -1, -4, 5, -1, -4. And then I write the second vector down twice on the right hand side. 3, -2, 5, 3, -2, 5. And I cross out the top row and the bottom row because I wrote them down for no reason. Then I'm going to multiply downs minus ups. So here I get -1 times 5 minus -4 times -2. So -1 times 5 is -5 minus, this will multiply to +8. So -5 minus 8 is -13. And right away, if you're looking at your last answer, we see that this is not the same. So let's try our y values. So here I've got -4 times 3 minus 5 times 5. So that's -12 minus 25 is negative 37. And I think that you probably see what's going on here. Multiplying downs minus ups, we've got 5 times negative 2 minus negative 1 times 3. So that's negative 10 minus negative 3. So plus 3 is negative 7. So we see here that V cross U is negative 13, negative 37, negative 7. So it's not commutative, but it does have a relationship, because we, obviously from the last one, we saw that that's just the negative of that, which I think should make sense when you look at the individual equations for the x's and the y's. If you swapped around those a's and b's, they're actually just the negative of each other. So is the cross product commutative? No, it is not. But U cross V equals the negative of V cross U. So there is that relationship there. If you know one of them, the other one is just the negative of that vector. And just to take a look at a few important properties. For the cross product, that's the first one. It's not commutative, but it is the negative if you switch the two vectors order. Distributive law for cross product absolutely still works. So if you have the sum of two vectors here, you could do U cross V plus U cross W. You have to be a lot more careful when you're doing the distributive law with cross product versus dot product, because this is not commutative. So if you had another one where you maybe got like a W cross U, you couldn't just like gather those like terms, because you have to be, again, careful of the order. The U here is first and these ones would be second when you do the cross product of each. Again, the scalar multiplication, it can be, that K value can be multiplied by either vector or by the final answer. You will just end up with a factor of K either with all of your U components or with all of your V components, or you could just do the U's and V's separately and multiply that factor of K in by your final answer. So that is the end of the Unit 2 Day 7 lesson on cross product.